Hello, everyone. Welcome to our talk today, DIY server-driven UI, or as I like to call it, how we turned web to Kotlin and got rid of those iOS developers for good.
You do still have an iOS team, Jimmy.
Well, if I can't get away with jokes like this at droidcon, when can I?
True, very true.
Anyway, on the topic of server-driven UI, this talk is about server-driven UI. Do people know the concept? How many people have heard of it before? Yeah, don't worry, we're not going into detail on what it is. Our talk today is actually about our experiences and us building our own. Our experiences, our approaches, the challenges we've faced, and how we feel about it 4 years on. At this point, it's probably good to introduce ourselves. I'm Jimmy Ray.
I'm Harriet Taylor.
And we're both Android developers at AutoTrader. A quick outline of our role. We look after the Android mobile app. We've got some gateway services that we run and some back-end services as well that are all in the app team estate. These are mostly in Kotlin now, but we do have some legacy Java code that we're trying to phase out. There's the iOS mobile app as well, but we don't really talk about that here. Today, we'll start off with an intro, which is the bit we're in now. Then, as all good stories do, we'll start at the beginning, which will explain a bit about us, the problems we faced, and give a little overview of server-driven UI for those who don't know about it. Composing Composable will cover our approach, building our framework, and what it does. And then we'll have some tech insights where we'll look at how we handled versioning, the DSL we've built, and some dynamic UI and form handling. We'll follow that with a retrospective and a quick little look back over the past 4 years and some insights that we found. So, without further ado, you'll be glad to know the intro is now over, and I'll hand to Harriet to start at the beginning.
So let's go back to the very good beginning, which is a good place to start. And to understand why we decided to build our framework, it probably helps to understand who we are a little. So we're AutoTrader, and we are an automotive marketplace. Now, many people in the UK probably still remember us as a classified ad magazine from back in the day. Now, we went online in 1996, and that was before Google existed. No idea how people found us. We're still here, so clearly something went right. And we actually went fully digital about a decade ago, so the magazine stopped publishing in about 2013. Now, we are the biggest automotive marketplace in the UK, and we're only 2 of technology companies in the FTSE 100. We serve over 18 million car searches a day, which is more than Google, and we get over 80 million visits a month. Now, our apps account for about 50% of all of our traffic, and we support around 3 million unique users a month. But despite all of this, our team had a predicament. So we've got a load of traffic, but we only had a small pool of developers. We had about 6 Android and 5 iOS at the time. The web team were a lot bigger, think like 70 plus developers on web. Now, we've got to write everything twice, we've got to test twice, and we've got to test even more because we can't roll back once we've released our app. And we were supporting all the same features as web with twice the amount of work and a tiny team. Now, how many of you know this pain? Come and think. And then there is the release process. So, I'm sure you all know this one. You write the code twice, then you've got to test it, then you've got to push it to the store, then you've got to wait for approval, and if the app isn't rejected for a daft reason, like they can't see a button, we have had that happen before, then we stage a rollout over the next 7 days. And then after that, it can take up to 2 weeks for the new client to be downloaded by about 85% of our users. So that's up to a month for a change, and just to get into our users' hands. So if you compare this to a server release, code, test, release. Pretty simple. So with a large web team doing quick releases and tons of product requests coming into us, we found it quite hard to keep up. We were behind web. Android and iOS weren't even aligned at this point, and we were getting to features months or years behind the web team. And by the time we picked things up, the original team had gone. The product owners and designer had moved on to other projects, and we were pretty much on our own. So we decided we couldn't keep going on like this. We considered a few different options at the time. So there was cross-platform apps like Flutter or React Native, but these had too much upfront work for us. We had over 12 years of code and features in our apps, and it would have been a big change to try and sort of move over to this. And we also needed to enable the web teams to work on the apps and to open up our code base as well. We also discussed web views, but for a number of reasons, they weren't really for us. We kind of wanted to keep a native feel of the app, and we didn't want to push our users out into web views, really. So we'd seen a few talks and discussions on the idea of server-driven UI. One of those talks was actually here at droidcon in 2016, when Spotify explained their component-driven UI system. I think it was called Hubs. And Airbnb, and I think a few other companies at the time, were also talking about this. If there's any Spotify or Airbnb people in here, thank you, because you inspired us. And yeah, it seemed a really good solution to our problem. It gave us a way for our teams to update our own products without app skills. We could open it up to web, and the app team to have a single source of truth for both clients. Now, just talking a bit of the traditional client-based UI. So the app calls out to a server, it'll get that raw data back, and all of the business logic and UI definitions live on the app client, and it knows what to do with that data. This means that most of our updates need to be done on the client. Talking about server-driven UI, though, that will move the logic and UI building to the server, and the clients request a page instead of the raw data, so they get a UI definition back. They can then build that UI with no knowledge of the data that it contains, and if you want to update a screen, you can now do that on the server, and then the clients will get that UI. And that seemed to solve a lot of our problems. We'd only need to write features once. The logic would be shared between Android and iOS. Non-app developers could easily build and change things. Releases would be simplified. We controlled this so we could add it into our apps rather than rewriting them. However amazing this sounded, there was still one problem. How on earth do we get time to do this while keeping up with products and feature requests? Jimmy.
So we knew what we wanted. We wanted to build a server-driven UI, and we knew we'd build our own. So it was time to tackle probably the hardest question of the whole lot. How do we name the thing? I'm going to address the elephant in the room. Yeah, we've said it a few times. We called it composable. Now, at the time, we were talking about design systems. Swift UI had just came out. Jetpack Compose was in preview. It was all a buzz saying, oh, screens are composed of components, and it's great. So, as an Android developer, getting the Android-sounding name sounded really, really good. This is until the 50th code review saying, do you mean Jetpack Compose or composable? Or coming to stuff like this, saying, our composable components are built using Jetpack Compose composables. Yeah, to clarify anyway, components and composables for this talk are generally about our system. Let's get back to the problem though. Where do we start? We're overloaded. We have this massive backlog, and building a big framework isn't an easy task. We had some discussions. We came up with some ideas. In fact, we came up with a whole bunch of ideas. Conversations got really long. There was loads of requirements. It just went way out of control. So we did probably the most agile thing we've ever done. We decided we'd just build what we needed at the time. So we'd pick a product, and for that product, we'd build enough server-driven UI as we needed, and then evolve the system over every product that we needed to build in future. It'd take us a little bit longer to deliver these products, but in the long run, it would be better for us. We planned versioning ahead, so that solved a lot of arguments about, oh, well, we might need this thing. Well, we don't, because we can add that in future. We'd only support apps, so there's no worries about building web layouts or other complexities we didn't need to worry about. And we'd take a hybrid approach. So we'd use server-driven views within our existing layouts, so we didn't have to rewrite all screens and other areas. I'm sure if any of you have ever tried to rewrite a product page or something that's really, really big, and you get like 3 months in and you realize that it's still not feature complete and you probably need to scrap it and use the original code. It's not good. We decided a component should be self-contained. It can be configured by a schema that defines how it looks. It can draw its own UI, but it doesn't have to. And any interactions that didn't just update the state within it are propagated up. They can have children, but they don't really know anything about their children. They can do the layout and they can propagate the actions up, but they don't interact with them. And this lets us build up a node tree, very similar to the sort of trees that you get with Jetpack Compose and other systems that use the same layouts. We already had a design system, so it was quite easy to know a list of things we could pick from. And the language and tech, thankfully, wasn't too much of a problem. We thought about it for a while, but as we're a big Java house at AutoTrader, Kotlin was pretty easy to sell to the web devs, and it was easy to sell to the Android team, a little harder to the iOS team. Mm-hmm. But it worked with all the common tech. We could use Spring Boot, Gradle, all that lovely stuff. The DSL, we knew that would be good in the future for building these layouts. And Kotlin multi-platform at the time was in its infancy, but we knew we could start leveraging it later on. It also scared iOS devs, which was brilliant.
I think you're just jealous they write better Kotlin than you now.
It is. Anyway, we're already in an okay place with the service architecture. Our clients called to a gateway service, which spoke to a legacy backend. It was quite complex, all in Java, and had been there for years, but it still protected us from the rest of the AutoTrader estate. This meant that we could keep all that stuff and add a new server-driven UI backend for front-end. This would be the only point that renders our server-driven UI and would hide the library that rendered it. The legacy backend can call into that backend for front end, so you've got this kind of like unidirectional flow, so you can't communicate backwards with each other. And on the clients and the servers themselves, we ended up with a client library for Android and iOS to read the UI definitions, business logic and definitions all on the server, and a composable library to build up these schemas. The first screen we took was a very simple one, just a little info screen. For that, we had some buttons to get into the page, an image, some really, really, really basic text at the time, and some dividers and spacers, which obviously you can't see because it's a spacer. We started off with versioning straight from the back because we knew we needed to improve it, and later on we added a Kotlin DSL. We'll go into this later in the tech insights section. And then about 10 months later, we added handling for dynamic UI and forms and input. So for the first 10 months, all we could do was show a screen. Couldn't do anything with it. It took about a year or so of actually using it before we added rich layouts and richer text. And then as projects went on and came in, we added more and more until now we're on version 12. We can support most of the design system, and most of our team have actually contributed to it. I think everybody in our team has either built a component themselves or they've added to the framework. As you can see here, all the blue sections are server-driven. The white sections are still the client-based sections. Some of them are probably, way old. We've built parts of screens. We've built whole new flows. We've built loads of different things, all just from this one container part. The results of this? Whenever we build new features, we now first say, let's build it in composable and replace anything that was on the client. We've got more and more shared logic between Android and iOS. The platforms are more aligned than they ever have been. There was a time when we had completely different features on each. It was hard to keep up. We've inherited a pile of web developers by proxy, because now when they're building their products, they can build it on the apps. And we've also grown, so we've gone from a team of 12 to about 32, 33 now, which is also a bonus. Which has meant we've had much, much, much more time to do native fun stuff, like dark mode. Yeah, we made ourselves hoodies. Fixed a load of tech debt. We've had time to look at cool stuff like KMP. And talking about KMP, we started leveraging that quite a lot recently. Android and iOS, as needs arise, and we've needed to fix a bug or we've needed to change something, we've moved the composable logic over to Kotlin multi-platform, so it's all shared. As we've added tracking with new features, we'd see problems where iOS would send one track, Android the other, so we started moving that into Kotlin multi-platform. And things like web repositories for new features, they're all done in Kotlin multi-platform. Our Spring Boot server generates JavaScript, so I'll go into that in a little bit of detail later, but that's really cool because we use JavaScript, but we never touch it. And the biggest thing is the data models. Because Kotlin runs our server and our clients, the data models are shared between all three. So all the different composable versions that we have, the schemas for that all use the same library. There's no mistyping or bad deserialization. There's no, is this field nullable or not? Well, we know because it's all in the same library shared across everything. Talking about those tech insights.
Let's start off. So we're going to begin with how we handled our versioning. So we knew from the beginning versioning was going to be key, and we needed to be able to add and change on demand as we built the system, and the server code would be pretty flexible. However, our clients still needed to go through the release process, and we know many users don't update the app, or they might not be able to update them because they might be on an older operating system. So that means that we need to be able to support multiple client versions at once. So thankfully, the clients keep clean. They don't need to worry about the versions. They can just support the one API version they were released with. The responsibility of versioning for us lies on the server. So the server makes sure the clients only get the response that they can support. The core solution for adding new functionality and components is pretty simple. So each endpoint has a minimum version of an API that it can support. In this case, in this example, we've gone for 1.9. So a client, the same API version hits it, we know it can render the UI, so it gets the UI back. Now, a client with a higher API version can support that UI too, so we send that UI back. A client with a lower API version might not be able to display some of the components, so we'd send back an error. But what happens when we change existing components or functionality? So the clients can still show the UI, but they just might expect a different response structure. I'm sure many of you know the pain of trying to change a data type in JSON payload from, let's say, a string to an int. Like, you'll get a malformed response. So here you can see where the text structure is massively different in 1.3 and 1.4. In 1.3, we just had rudimental text. In 1.4, we changed that to attributed strings. So you can see that difference there. And this is where we add another layer of versioning at a component level. So each component has its own render function that takes in the version, and it then renders its own JSON based on the client version. So in our example for 1.4, we changed the payload for text. A 1.0 and 1.3 client both get the original payload. A 1.4 or higher will get the 1.4 version, and nothing will break. So this pattern can be repeated for all parts of a response, and each object is responsible for its own rendering depending on the version. We can support different UIs as well for different versions. So in this example, we added some features, meaning we could add the banner and bullets on the newer clients, and the older clients would just get the original UI that we created. And that brings us on to the DSL, or domain-specific language, in case you were wondering, because it has been mentioned a few times now. So what is this? It's a language or a subset of language built for a specific purpose. Think like HTML for web, or like SQL for like databases. And I mean, who enjoys writing a ton of pure JSON and remembering a full API? I don't think anyone does. So RDSL solves that issue. So jumping back into that first page we made that Jimmy mentioned before, this is how the page is currently defined in the DSL. So we've got some spacing, an image, We've got a header, there's some bullets and a description made with attributed text. Now, the amount of spaces isn't needed now because we've got richer layouts, but it's amazing how the first page that we built hasn't needed to change much as we've evolved. Like, there's a good reason for this as well. The DSL separates how we define a UI from our client contract, the JSON, and as you can see here, the DSL and JSON look nothing alike. So properties like font and color are restricted to design tokens in the DSL. In JSON, they're generic numbers and hex. In fact, the text is an attributed string. So what this does is it allows us to add and change colors and other styling as needed while limiting what the developers can use in the UI. And it allows us to version the JSON without changing old UI as well. And talking of versions, you might have noticed that we use feature set quite a lot. So when you build a page, you work within the scope of a feature set. And this is a set of components that API level supports. The DSL restricts it, so a developer can only add components available on that API level. So it doesn't stop developers building bad UI, but at least it won't crash the app. Now, the feature set scope allows for IntelliJ suggestions. So in this case, we're on feature set 1_3, so we get these options for components that we can add. Now, if you're on feature set 1, you'd probably see only 5 or so components because it was the initial one. Feature set 12, you'll get a whole bunch more, and some might even be removed because they'll have been deprecated by then. If you'd like to learn more about creating your own DSL, there's some links here, and these will give you a better overview than I can do in a few slides. I did try. And the last link there is written by our own Paul at AutoTrader, and he's explaining the DSL there for, I think he made some UI automation, so check that out. And that QR code will take you to a link to a blog post that we wrote about this with the links from this talk.
So this brings us to the final tech insight about forms and dynamic UI. The system we made originally was great at serving static content down, but we didn't have any way of getting user interaction or showing or hiding things or anything, any of the lovely stuff we need to do in apps. It wasn't long before we got a project that came in that needed all of this. It was clear that we needed some way to send something down that had logic and state in it that we could execute on the client, and then some way to send that state back up so that we could use it on the server and read from it. So we got together, had a talk, had some ideas. Most of those ideas didn't work. We'd seen about Redux, and we liked the idea and the core principles of it. So with Redux, it's a bit like MVI. The view or UI subscribes to a store. It can read any data updates from it. It can't interact with it. It can only interact by firing actions. These actions can then interact with the store through reducers. We skipped the reducers bit, and we made our own little version of it. So each component can ascribe to a store. It can see actions that it can execute. It can send data in on those actions depending on what component it is, and it can observe state. It can execute actions and observe state changes. Pretty straightforward pattern nowadays. Just do that again. Can't remember why I did it in a second time. So, if we've got a simple form like this, sorry, UX, we're on holiday, where I can enter my age in a form and get a message back. We could have the age input to call set age when it changes and observe the age as its source. And we could have the enter age box with the age message as its source. If I enter my correct age of 21 into this field, it calls the set age action with the value of 21. Because we don't know what the actions actually do, we don't care, we've just called an action, that could update the age field, but it could also update the message. That's then emitted to the UI. The UI observes that and updates. It's a very familiar pattern nowadays. So, we don't need to execute, send values across on everything. We can execute actions without a value. So it means it works for buttons as well. It works for all kinds of controls. So Submit, we may want to validate the input. We send out an action. It changes the... have you been messing with these again?
Don't know what you're talking about.
Cheers. Anyway, we see how it works. Jumping inside the black box a little bit, we have logic and actions. These are all in JavaScript. And we have state. The logic and actions are shared across multiple instances of the screen. So if we have a store on a product page, a user will only have to download the store for that once. Any subsequent visits, it's cached, it can be reloaded. But each different visit to a product page may have different state. The state is done per store. So the actual actions and logic that's in there, we don't need to copy, but we do change the state. And it's persisted, so if we need persistent sessions or session data, we can save that there. This can be sent up on request payloads. If a user enters a form or updates anything, we can get that data back. We've implemented this using Kotlin multi-platform in a few different ways. So the actual client-side logic is done in Kotlin multi-platform for Android and iOS. Now, originally it wasn't. There were some discrepancies with how things happened, so now we've joined that together. And the state is actually generated using Kotlin multi-platform JavaScript on the website, as described in the earlier slide. So we don't have to actually touch any JavaScript ourselves. To declare a store, we'll make a store description like this. As you can see, it's all just normal Kotlin. We have some annotations, so expose will say, this is something that we want to expose up to the store DSL. Vals and vars come out as properties, as state. Functions come out as actions. So we'll have a validate function on this, and we'll have an age message, an age field. We use this description to generate a binding that we can use then in our DSL. So when we build up a page, we can then have fields that are just tightly coupled and tightly done to that exact store. So there's no developers trying to tie strings up loosely, spelling it wrong, getting the wrong fields. You only have what's available in that store. And this has given us our way of sending some state and logic down to the client to be executed, and then sending that exact state back up on the server when we need to. Now, we're going to switch it up a little bit, and we're going to do a little retrospective. I'm going to pass over to Harriet to run it.
Everyone is familiar with retros, right? If you're not, we are going to have 3 columns. We're going to have went well, to improve, and actions. So we're going to start with the good column, and we're going to talk about what went well. Let's start off on a positive note. So first up, we've got not trying to do everything at once. Now, wanting to get everything right the first time made it hard to do anything to begin with. So versioning and pushing decisions down the line made it much easier for us just to start the process and get the ball moving. And the ability to spike and try and change plans after implementation definitely helped us, and it shortened a lot of conversations.
Yeah, keeping it simple. So we built quite a complex system, but the core concepts underneath it are quite simple. So the node trees for the components, the store using key value pairs for everything. We've actually rewritten that store 3 times. It started off as kind of like a CPU made out of JSON with like ands, ors, and nots that I was really, really proud of, but anybody using it wasn't. So it's been really crucial to allowing us to scale and evolve, really.
So then we've got the planned versioning. So that gave us tons and tons of flexibility, and it made it a lot easier for other teams to contribute as well. And it meant that we didn't have to go and rewrite tons of the existing UI code too. So that was definitely a really good one. Yeah, pulling in web team really, really helped actually. It's strange, you go from being an outside team making apps to actually being more
in line, and it's nice to see like the web developers and other product teams that would normally just throw new features over the boundaries and we'd put it in our backlog, and they start actually doing the features themselves and taking real pride in seeing it on apps and asking the question, what's happening on apps. And we actually learn quite a lot from as well. There's loads of different ways of working that being in your little app bubble for so long you kind of don't realise about.
Yeah, and there's always been new challenges with this. So app development can get a bit tiring when you're just making screen after screen. So with this, there's been so many opportunities to engineer and create exciting new technology. And it's given the team opportunities to do things they might not have done before or thought they could do. Like, I never thought I'd be on a server writing Kotlin in Spring Boot, but here we are. So let's move on to the to improve column. Don't want to get negative, but there are a few things that we probably could improve on.
Yeah, turns out that app developers like working on apps, not on web services. And there was times in the projects, especially early on, because we were developing it and developing our own features with it, because we were a product team, there was a lot of time when we spent a big chunk of work on the server. I'm talking maybe a year or two of all the features being built. But as we've evolved the system and as we've got it kind of like fleshed out now and the web teams are coming on board, we've got so much more time to actually do native work. So we took it on board and made sure that if anybody was feeling like they wanted to be a bit more happy, we could make sure that they got more native work, and there's always juicy bits there.
So many PRs, literally so many, it was crazy. But yeah, because suddenly we became not just a product team, but we were a platform as well. There were tons of PRs coming in, and support requests were coming in from web teams contributing. We've streamlined this a bit now by placing more trust onto the people contributing and the teams. So we've gone from our small app team to suddenly over 50 devs contributing across apps and web. Now, before, we used to need 2 ticks, so 2 reviews before you could merge a PR. Now we've changed that to only be 1 review on a PR, and all merges go straight to production, which sounds a bit crazy, but it does work. And web already used CD, like continuous deployment, so it's been working, it's good, and it gets the ball rolling a bit more.
It's a bit scary as an app developer when, if any releases you can't roll back, and then suddenly you can actually roll the back releases and update them really quickly.
Yeah.
Everyone's just like, oh, release it. Like, no, we need to test to make sure it's fine. Anyway, yeah. So, talking about testing, we only used to have the Android and iOS client and some server stuff. And it was pretty simple. Now we've got multiple different composable versions, multiple different client versions. We've got code that lives on web and code that lives in the apps. And it can get a bit confusing for ourselves which areas might have broke, let alone the web testers, wondering whether it's broken on web, wondering if it's broken on apps. But, after the initial kind of like bumps in the road sorting it out, it's got reasonably easy now. And the good thing is we can actually fix the stuff pretty quickly. We kind of hope it's an issue on the web, not something on apps.
Another one that we had was too many technologies. So we're using Kotlin, then we've got Spring Boot, KMP, KSP, Docker, different services. Gradle is just growing more complex in our project as well. Like, we both helped found the project, and I don't think we know some of the areas now. Like, it's grown so big, but that's good because it means that there's more room for people across the team to come in and specialize, and it means the knowledge is getting spread across as well. Like, there's no SPOF, like single point of failure, really. Yeah,
so finally, we've got a design system built, but we're still not finished. And the design system seems to grow faster than we can grow. So while we've got there and we can do a lot of stuff, we can't support every design, and we can't support all these nice, crazy things that people want to do. We can still do stuff client-side, we can still do piles of stuff native, and we do. But we can't get everything. And eventually we will do, but I don't know when that point's going to be.
So, Jimmy, did you add this?
So this should be in the good column, really. We've actually, the iOS team's grown. They've jumped on board. After initial tetchy times with them getting onto Kotlin, they actually really jumped on it. And it's surprising the different ways that, especially even just Android and iOS developers work. We've learned so much from each other and changed our ways of working so much in ways that I've just not really had when we've had separate Android and iOS teams, which has been, it's been really good.
So now we're going to talk about the actions or the future plans. So what are the next steps for us? As we mentioned quite a bit, KMP, so it's already in use within the project, but we're slowly sharing more code across platforms. We also want richer layouts, so richer layout handling like overlaying components, adaptive UI for tablets and foldables, because we're seeing more and more of our users on foldable devices now. We also want to make the content more dynamic with animations and transitions, add a bit of flair, like start thinking about making it a bit more native appy with that SDUI approach. And yeah, libraries and federation. So we want to further improve the PR process and support issues. So we're splitting off like the DSL to its own library, and we're going to break down the back end to multiple services owned by other teams, so it's not just all falling on us.
Yeah, it's with that our talks come to an end. Thank you for visiting. We hope you've enjoyed it and maybe learned some good stuff or some bad stuff to avoid and never do. We've got a slide with all the links from before, same QR code if you want to grab any of them. If you've got any questions that you want to ask us that you can't ask now, please drop us a line on LinkedIn and ask. Have we got time for any questions? Yeah. Any questions?
Yeah.
Yes, we have experimented a bit with Compose multi-platform. We're in early stages with stuff, but one of the things we're actually looking at is doing an IntelliJ plugin to do all the DSL and the UI generation, because we've got it hooked up with emulators and we've got everything so design and the web teams can like launch whatever they want. But we could also do that as a nice little side thing in IntelliJ. Most of our apps online. It will, if you open something that has been previously loaded, it'll still show fine. But we do search, we do other things that are mostly online. Anything offline as well. We do have native components that, well, all the components are native, but we do have ones that are just client-side anyway that can handle stuff like that.
Did you face any challenges when communicating between your server-driven components and your native components?
With the way we handled it, the hybrid approach, we've not really hit many issues like that. We've had to do some flows, we've had to do those completely native client side, but we can trigger them from the server-driven components using the actions. So, for example, sign-in processes, you wouldn't want that through a server-driven UI. So that's all native, but we can still hook into it.
Have we got any more?
Yeah.
Yeah. Yeah, we have been discussing this recently, and I think it is somewhere that we might want to go in future. Right now, everything is internal, but I have heard word within the apps team that we might want to start making what we've been building open source, but not quite now. Yeah. Any more questions? Yeah. I can't hear, sorry, could you repeat that? Right. Yeah.
We've not seen that much of an impact yet. With our tech estates, it's pretty bonkers. It's really on top. If any server goes over a slight error or memory threshold, it pulls the whole team into a channel in Slack and tells you, and then like you've got to click acknowledge or people start shouting at you. So while we've been doing it, it's actually the legacy backend that's been the most troublesome. The new one's been fine.
Yeah, so we're actually phasing out the legacy one at the moment. We're hoping to get it out by February. Whether that will happen, we don't know. But it is like we're trying to move everything over to the sort of newer system and get rid of that older one. You're stuck in that hell at the moment, aren't you, Jimmy? Yeah. Any more questions? No? Okay. Well, thank you for coming to our talk, and we hope you've learned something.